Leaf Detective by Heather Lang, illustrated by Jana Christie. We are a part of our ecosystem, not outside it. Margaret Canopy Meg Lohman. Meg loved how leaves burst into the world and unfurled. She admired their different shapes, colors, and textures. After 20 years of thinking about them, reading about them, studying them, Meg wanted to understand them, to discover their stories. How did they survive? How long did they live? Why did they die? But looking at leaves from the ground, as a rainforest scientist, only so far, Meg knew she had to find a way to go to the leaves, to the treetops. We had already been to the moon and back, and nobody had been to the top of a tree. Before 1979, most scientists studied rainforest treetops through binoculars. Some also cut down or sprayed them with chemicals and collected the dead leaves and insects that fell to the ground. Meg Lohman had been a leaf detective ever since she was a young girl. In the 1950s in Elmira, New York. Shy and studious, Meg rarely spoke in school. It pained me if I was ever called upon in class. Instead, she found comfort and friendship and quiet excitement in plants. She built trees, tree forts, and collected twigs, leaves, and wild flowers to study and identify, to press and label. Swamp thistle, devil's paintbrush, forget-me-nots. I was literally the only one in my town like myself. Meg wrapped herself in nature like a soft blanket. In college, Meg fed her passion with science. She was a young woman in a jungle of men, with no women to lead the way. One professor refused to let her in his class because she was a woman. Still, she stuck like sap to her passion and followed it to graduate school in the tropical rainforest of Australia. No one at university had studied the rainforest before. Tropical rainforests receive at least 60 inches of rain per year. The hot, humid environment encourages lots of different plants to grow. This diversity supports a huge variety of animal species. In the dark, damp forest, the trees rose up to distant rustling, squawks, and screeches. Shadows in the treetops. How could she get up there? Using the seat belt straps, Meg sewed a harness from a metal rod. She wielded a slingshot. Pull, aim, release, fire! Meg launched a lead weight on the line, again and again, until at last it caught around the sturdy branch of coachwood tree. Most rainforest trees are between 60 and 150 feet tall. Their branches from the canopy, a big umbrella that shades the forest floor. At first, Meg flailed upside down, right side up. The steamy forest painted her with a coat of sweat. Swinging and twisting, she dangled like a worm on a hook. I was frozen with fear. Meg inched up the rope, but she worried. What if the branch breaks? Will my swing hold up? Will a bird hack through my rope? What sits waiting in the treetops? At last, splashed with flowers and sunlight, the canopy. The treetops swayed back and forth. Flies whizzed, lizards lingered. A black weevil sucked leaf juices. Sweat bees landed on her arm for a lick of salt. And the jungle's music danced all around her. From then on, I never looked back or down. Insects ate leaves by chewing them, piercing and sucking from the leaf, or tunneling in and eating the inside of the leaf. To Meg, it was a secret world with brilliant parrots and sleepy koalas, slithering pythons and busy ants, and leaves, lovely leaves, large and small, shiny and prickly, tender and tough. To scientists, it was a new frontier, mysterious and unexplored. Now believe the canopy is home to approximately half the plant and animal species on land. Many people in Australia didn't understand Meg. They thought the rainforests were dark and gloomy and full of snakes. They wanted to cut them all down. By the 1970s, deforestation, the clearing of forests by humans, had become a serious problem in Australia. And around the world, scientists guess that more than half of our forests have already been destroyed. You can't do this, people said. You're a woman. Women don't climb trees. Meg ignored them. Rainforest mysteries called her to climb and discover. She climbed the Red Cedar, the Antarctic beach, the sassafras. She explored the stinging tree. It defended itself. Its pincushion leaves tore at her skin, and chemical hairs inject poisonous with a fiery sting. Trees can't run away from their enemies like animals can, so instead they have to make a lot of defenses. Thorns, fuzzy leaves, toxins. Plant chemicals can be used as medicines for humans. For example, chemicals from the rosy periwinkle found in Madagascar provide a cure for leukemia. They have learned how to use a very small number of the world's medical plants. On each tree, Meg numbered leaves on different branches. At different heights, she monitored and traced them to find out how long they lived. Hour after hour, day after day, she worked alone in the treetops. I found these times alone to be very strengthening, as they encouraged me to develop confidence in myself. With each new climb, Meg discovered nibble edges, lacy skeletons, and leaves that vanish quick as a snake's prey. She wondered what is eating all these leaves. One night, outside her tent, Meg heard sounds in the darkness. She crept into the forest. Noises swarmed around her, munching, crunching, chewing. With her headlamp, Meg scanned the leaves for a coachwood tree and discovered walking sticks and beetles feasting. To my amazement and delight, most herbivores fed at night. Herbivores are animals that eat plant material. Meg discovered that 15 to 25% of tropical rainforest leaves are eaten every year, mostly by insects. To insects, a tree is not just a tree. It is a salad bar. All you can eat leaves. To birds and mammals, a tree is a buffet. Juicy fruits and plum beetles, salamanders and frogs. A tree is a sponge, soaking up water from the forest floor and the recycler, giving water back to the clouds, ready to quench another day's thirst. When animals eat leaves and feed on dead and weak trees, they return nutrients to the soil through their swaying roots, nurturing trees and future seedlings. Trees release water from their leaves in a process called transpiration. This water forms rain clouds. Moisture from the Amazon affects rainfall as far away as Texas. Meg tried to climb at night, but dangling from ropes, studying leaves is difficult and dangerous in the dark forest with deadly snakes and spiders and ravenous biting ants. She had to find a better way. She brainstormed with other scientists. She thought and imagined. What if I fly up in a balloon? Or work from the edges of hillside? Or train a monkey? Then one night, at one of her research sites, she and a friend had a brilliant idea. A trail through the treetops made with ladders instead of ropes. They sketched the plan on a napkin. Meg helped invent the world's first canopy walkway. Now she could research day and night, in good weather and stormy, alone and with others. In 1988, Meg and Peter O'Reilly designed the canopy walkway at his rainforest retreat in Queensland, Australia. It had tree suspension bridges and reached a height of 110 feet. Meg loved to give tours on the canopy walkway. Now Australian people wanted to visit their rainforests.